Hi everyone, Professor Lamar here, and welcome to our mini lecture video about correlation coefficients. Let's go ahead and get started. Correlation coefficients are very useful in correlational or non-experimental research. And they're really useful because they give researchers a very quick and efficient way to understand two key pieces of information. Correlation coefficients tell researchers the strength of the relationship between two variables and the direction of the relationship between two variables. So they tell researchers if two variables are strongly related or weakly related or maybe moderately related. And they also tell researchers if that relationship is positive or negative. Now, quick disclaimer about correlation coefficients before we go any further. They actually don't work for curvilinear relationships. They only work for positive or negative relationships. So there is a bit of a limitation there, but otherwise they're very useful because researchers just look at a number and they're instantly able to tell if a relationship is positive or negative and how strong that relationship is. Now, one of the most well-known and frequently used correlation coefficients is the Pearson product moment correlation coefficient, which is represented through the lowercase r. Now, that's a mouthful, so I usually just call this Pearson's R, and that's what you'll see a lot of the time as well. Pearson's R ranges from +1 to -1. And typically you'll see values that are less than +1 or smaller than -1. But if you ever see a +1 or a -1, that indicates a perfect correlation. If we have a perfect correlation between two variables, that means that if we know scores on one variable, we can predict with perfect accuracy scores on the other variable, which is pretty cool. Now, however, perfect correlations, again, are very, very rare. So typically you'll see something that gets close to 1 or -1, but just isn't quite there. Now, let's talk about the difference between +1 or -1 though, because both are perfect correlations. So how are they different? Well, it's just the signage in the front. A +1 is obviously positive, which indicates that it's a positive relationship. A -1 is obviously negative, which indicates that it's a negative relationship. That means that when you look at a correlation coefficient and you see a negative sign in front of it, you know that that's a negative relationship, whereas one variable increases, the other variable decreases. However, if you don't see that negative sign there, that means it's a positive relationship. And that means that as one variable increases, the other variable increases as well. All right, now we know what a perfect correlation looks like. It looks like one of the ends of this range for Pearson's R. But what if two variables are not related at all? What would that correlation coefficient look like? It'd be a 0. A correlation coefficient of 0 indicates that there's no relationship between two variables. What that means is that if we know someone's score on one variable, we cannot predict their score on the other variable because, well, they're not related at all. There's no relationship between them. And again, I mentioned that it's rare that you'll have a perfect correlation, but you could totally have two variables that are not related in any way. And you might be wondering, okay, well, how do I classify correlation coefficients as like being not related or weakly related or strongly related? Well, here we go. If a correlation coefficient is greater than the absolute value, that's what these two vertical lines around the 0.59 represent. If a correlation coefficient is greater than the absolute value of 0.59, then it's strong, okay? A strong relationship means that if we know scores on one variable, we can predict with decent accuracy scores on the other variable. Now, if a correlation coefficient is less than the absolute value of 0.3, it's considered weak. That means that we can kind of predict one variable if we know the other, but there's a lot of variability there and it's a pretty weak relationship. We can't really predict it with a lot of accuracy. And anything in between those values is classified as moderate. So anything between the absolute value of 0.3 and the absolute value of 0.59 is considered moderate. Now, these classifications of strong, moderate, and weak, these are very commonly used in psychology, and that's why we talk about them in this class. But there's also other ways to classify correlation coefficients. Like you might see 5 different classifications, like very strong, strong, moderate, like weak, very weak, and things like that. And they'll have different cutoffs. Ultimately, that's because this interpretation is subject to what someone feels is best for the variables that they're studying. The classifications that we're using are the ones that are most commonly used in the field. And I like to keep things simple, just having 3 different classifications: strong, moderate, weak, and that's it. So that's what we'll do in this class. Okay, now look at what's changing between these classifications of strong, moderate, and weak. It's the number itself. So if you see a correlation coefficient, it's going to look like R equals maybe like 0.75 or 0.29 or something like that. And look at the number to tell you how strongly the variables are related. That's how you'll classify it as strong, moderate, or weak. But then look at the sign in front of that number. If you see that it's like if there's no negative sign there, then it's a positive number, and that means it's a positive relationship. If you see a negative sign, then it's a negative number, and that's a negative relationship. All right. So let's do a couple of examples. I'm going to throw out some correlation coefficients, and I want us to start kind of practicing how we would interpret these. All right. So first, R equals 0.97. What do you think? How would you interpret this? This is strong and positive. Very good. We know that it's a strong relationship because this number, 0.97, is greater than the absolute value of 0.59. So it's a strong relationship. Also, 0.97 is positive, so it's a positive relationship. This would be positive and strong. Next, we have R equals negative 0.63. This is negative and strong. Awesome. Now, for the next couple of R values, we're also going to throw in some P values too. And this is the key. You see, R tells us the strength and the direction of the relationship between 2 variables. And if you've taken stats before, you might have heard of this thing called a p-value. P tells us if that relationship is significant or not. Okay, so let's put it all together. We have an R value here, 0.14, and a p-value of 0.23. Now, R and P are different things. What does R tell us again? It tells us the strength and the direction of the relationship between 2 variables. The p-value just tells us if that relationship is significant. And anytime that p is less than 0.05, that relationship is significant. I'll say that again. Anytime that p is less than 0.05, that R value or relationship is significant. So here, this p-value is 0.23. Is that greater than or less than 0.05? It's greater than, right? And so does that mean that this relationship is significant? No, because p has to be less than 0.05 to be significant. So looking at this here, if we were to interpret this, we would say that there is a weak, positive, non-significant relationship. Again, we look at the correlation coefficient to know that this value, 0.14, is weak. We look at the sign in front of it to know that it's positive. And then we look at this p-value of 0.23 to know that it's not significant. Let's do one more, and then we'll talk about p-values just real quick to go over it again. Here we have R equals negative 0.45, and P, this is a less than sign, is 0.05. We also have 2 variables here, stress and sleep, okay? So now we're starting to kind of bring more things into this again. What we would do to put this into a sentence is say, starting with the correlation coefficient, that there is a moderate, it's 0.45, negative, because there's a negative sign there, significant, because P is less than 0.05, relationship between stress and sleep. I'll say that again as just one complete sentence. there is a moderate, negative, significant relationship between stress and sleep. This sentence structure is really important, and I want us to get this down and really practice this. This is something that, I don't know, you could see on an exam, or in the very least, you will likely see this in research articles. And for your research project, if you have variables where we run a correlation, which is highly likely, then you will have to interpret these correlations using the sentence structure. So let's practice it again. Remember, we start with R and we state the strength and the direction of the relationship. Then we look at P and we state if that relationship is significant. And then we look at the variables that we have, stress and sleep, and we just state those. So putting it all together, we'd say that there is a moderate, negative, significant relationship between stress and sleep. Now we know that R and P are not the same. R tells us the strength and the direction, and P tells us significance. But let's talk a little bit about P again. Remember, if P is less than 0.05, that means that the relationship between the variables is significant. So anytime that this P value is less than 0.05, either because it has a less than sign, or it's actually smaller than 0.05, like here, P equals 0.02. These things are significant. But anytime that P is equal to or greater than 0.05, it is not significant, okay? So if P is less than 0.05, it's significant. If P is greater than or equal to 0.05, it's not significant. Okay, so let's put these things, let's put the last two correlation coefficients together in sentences just one more time to make sure that we have it. Let's look at R equals 0.14, P equals 0.23 first. We would say that there is a, indicate the strength, weak, direction, positive, significance, non-significant relationship between variable 1 and variable 2. And that's what you see up here on the top left of this slide. Then, if we look at the second one, we would say that there is a moderate, negative, significant relationship between stress and sleep. Now, I want you to kind of get some practice with other correlation coefficients, and we'll have lots of examples in class as well. But I really want us to be able to start writing these sentences where we indicate the strength first, then the direction, then the significance, and then the variables. In the real world, it is technically okay if you indicate something like the direction first, and then the strength next. You could say there's a negative, strong relationship or something like that. But for this class, I really want us to focus on saying the strength first, because it's more common, then the direction, then the significance, and then the variables. So there's 4 components of this sentence, and that's what they are. All right, so this brings us to the end of this mini lecture video, and I will see you on the next one. Bye.